So we are back doing this relatively difficult question for problem 11 on the AMC 12B 2016. So it's asking how many squares whose sides are parallel to the axis, which means it must be an actual looking like a square, not like a diamond, just a regular square, and whose vertices have the coordinates that are integers lie entirely within the region bounded by the line y equals pi x, the line y equals negative 0.1, and the line x equals 5.1. So at first glance, this sounds like a very daunting problem. All the answer choices look very large, and yeah, this question, you will unfortunately, pretty much the best way to solve this is to actually count the number of squares, and that can be very time consuming. So if you put this, or if you found this question on the actual test, you would want to skip this question, but for the sake of this video, I'm going to show you how to do this and the most effective way of really drawing this triangle. By the way, this spoiler that this region bound is just a triangle. So I can try and sketch this out. I'm not good at making actual sketches, but it should look something like this. So it should approximately be around here. This y equals negative 0.1. X equals 5.1. So let's say it's like right over here. And then it's going to look something like that for y equals pi x. And you have all these decimals and these irrational numbers, and it's just, overall, you want to skip a question like this, and it just sounds so confusing. Like, why does it have to be 0.1? Why does it have to be y equals pi x? However, if we really draw this out, it's going to look a little bit something like this, and you're going to have squares keep on going up here. It's going to look approximately something like this. Oh yeah, and also the coordinates must be integers, so it's going to look a little bit something like this. I'm not going to draw the whole thing out, but to give you an idea. So, now that we have an idea of it, we're going to create a new picture. This is going to be a more accurate picture. So, on this test, or not really on this test, but on this problem, you're going to want to really draw a nice coordinate. Something that's like really large on the x and y, gives you a lot of space. So, when you draw the bounds, what you really want to do is you want to plug in numbers and see where these bounds meet at. So we know that it's going to look like a triangle like that. So all we really needed to plug in is x equals 5.1 and y equals pi x. That's all we need to really find. So plugging it in, you have y is, sorry, not x, but y is approximately equal to 3.14 times 5.1, and that's going to approximately be 15. So all we do is we just omit these decimals. These decimals are pretty much not needed, and that means that we can pretty much omit these decimals, and we can omit this pi and turn it into 3x. And the reason why we want to do that is not only because it's, first of all, you do this because you want to simplify it. So turning these into actual integers makes your life a lot easier. And also, as shown in the previous graph, you can see the squares did not touch y equals pi x, but it just barely missed it. The magnitude of 3.1 is so small it would not affect it, since the coordinates are integers. There's no squares that can really touch it or will be affected with it at all, because 3.14 times 5.14 is still going to be like 15.3. It's so small it can be rounded down, and the magnitude of the 0.1 of the decimal is so small that it can just be omitted / ignored. So we're going to really ignore this in order to help us a lot. So now we know that y is approximately going to be 15, so we're going to need to create quite a lot of coordinates. So I'm going to try this out. 3, 4, 5, 10, 11, 12, 13, 14, 15. So this is going to be 15 right over here. And I like to just label these multiples of 3's. I'm going to erase that because that's incorrect. But yeah, we're really going to try and label these in 3's and then try and equally space this so we have an accurate diagram. And first one's going to end up here, second one's going to end up here, third one is going to end up here, and the fourth one is going to be kind of tough. Just going to draw little dots. It's going to end up approximately here, and the fifth one is going to approximately be around here. And I'm going to erase these. Maybe put this a little bit more to the left because that was not a good one. But yeah, it should look something like this. And I wonder if I can have a line creator. No, there isn't a line creator. So unfortunately, we're going to have to draw a pretty bad line. And I'm not good at drawing lines. So this is y equals 3x. This is x equals 5, and of course we can turn the y equals 0.1 because it's so small, like it's not going to affect it at all. This is y equals negative 0.1x, but we can just turn that. Similarly, we can apply these same rules, and then we can just turn this into y equals x, or no, not y equals x, y equals 0. So now we have this pretty bad looking diagram, I'd say, but now we can try and etch out some squares. And in the real test, you don't want to waste your time doing this, but for here, we're gonna do that. So if we create a square here, it's not gonna work out because you can see it's not bounded by this triangle. Similarly, if you do it over here, it's not gonna be bounded by this triangle. And also over here, it's not going to be bounded. So our group of squares are going to be bounded within this region. And the same thing happens with here. You can't create a square here. No, that won't work out. So we're going to first that. You can only create it from this, starting from this 6. So we're going to create little dashed lines. And as you can see, this trend increases for every group of 3. So we can just create these groups. Now, you can see this is at 4, the 4 coordinates. So we're going to etch it all the way down, create these individual squares, and it allows us to create a square over here. And now we can start labeling it from these coordinates, and we have little unit squares we can count. As you can see, there's just unit squares divided into 3. So now, with these unit squares, we can count the number of individual squares. So we're gonna kind of label it off. So we're gonna have unit squares, 2 squares, 3 squares, and that's pretty much the maximum we can have, because you can see we can't have a 4x4 square because we're missing this square. So we're gonna kind of underline these. We have this, and we can easily count these number of unit squares. As you can see, it goes 3 because there's 3 unit squares, And then there's 2 times 3, which is equal to 6. This is 3 times 3, which is equal to 9. And then this is 4 times 3, which is equal to 12. So now the number of unit squares is 3 plus 6 plus 9 plus 12, which is equal to 9 plus 9 is 18, which is equal to 30. So now we can erase this. So now next we're going to try and count 2 squares. And the best way to count 2 squares is if you, well, not 2 squares, sorry, maybe just to make it sound better, 2 by 2 squares and 3 by 3 squares. So the best way to count them are in 2 by 2 groups, and I suggest counting them downwards because it counts every single square in that column, and you only have 3, columns? I'm not sure if you should call it columns, but we're going to call it columns. So this is 1 column, 2 columns, and 3 columns. And if we call them across a row, there's more rows, and it's just going to get more messy. So columns are the more ideal way to go. So I don't know how I should really count this out, but can, I guess, do this. So I'm going to count 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 here plus, so we have 8 plus 1, 2, 3, 4, 5. 8 plus 5 plus, maybe we should draw little lines to differentiate it. 8 plus 5 plus 1, 2. So we have 8 plus 5 plus 2 is equal to 15. And at last, our final one is going to be 3 by 3 squares. Oh no, I don't know how I'm going to count this. So we're going to have 8 plus 5 plus 2 right over here. So go back here. 8 plus 5 plus 2 is equal to 15. And now last we're going to count these 3 by 3 squares starting from here. So we're going to count down. So 1, 2, 3, 4. And now we're going to shift across the column and 5. So overall we have 4 plus 1, which is equal to 5. So overall our total number of squares is equal to 30 plus 15 plus 5, which is equal to 50. And for over here, problem 11, 2016 AMC 12B, your answer is D.